Hello.
Yes, I'm here. Can you hear me?
Sir, will you please share your screen?
Just one sec. I thought I was sharing already.
Okay, sir.
Uh, presentation. Okay. Can you see this presentation?
Yes, sir. It is visible.
Perfect.
Shall we start, sir?
Yes, ma'am. Madam,
Yes.
start now.
Okay. Okay. Very good evening to all of you, and I welcome you, sir, Mr. Sandeep Mahajan, sir, on behalf of CAST, MPKV Rauri, and the organizing team. I welcome you for this online training program of fundamentals of robotics for precision agriculture. So I just like
Oh,
to give a brief introduction of Mr. Sandeep Mahajan. He's a computer engineer and he's completed his MBA from Symbiosis University. He is currently working as a general manager in advanced engineering and technologies, John Deere, from the past 14 years. He is having a total experience of 20 years in automotive and process control industry. He is also having 5 patents on his name and 16 invention disclosures in the area of advanced machines. So again, I welcome you, sir, and I request you that you can start with your presentation.
Okay. Thank you. Thank you very much. Thanks for the opportunity to present. So the topic I've been asked to present is robotics and electronics in precision farming, and I'll try to give industry perspective. What is happening in the ag industry when it comes to precision farming. Okay, and before sharing my presentation, I would like to kind of give a small disclosure that this information in this presentation is actually a compilation of my experience with the industry, my understanding with and information of from various forums like the conferences I have attended, the trainings I have attended, the projects I have been working on, or the video series or trainings I have gone through, and overall experience. So I'm trying to compile it in my language, and these are all my understandings. So if there are any deviations, or if you guys have any other thoughts or views, please feel free to educate me as well. Okay. So the automation journey in agricultural sector, will take a quick look around it, because automation journey is actually leading us to precision farming, and how the machine automation is getting into autonomous is something we'll talk together. So the journey really started into 1920s, where there was a boost of increased productivity through mechanization, and earlier it was all manual or animal labor that was used in the farming sector, and mechanization really started with like engines in the machine and farming equipment that could really drive something. 1940s came the self-propelled machines, and they like the tractors we talk today, and the tractors today are pretty advanced, but that's something started in 40s. Increased productivity through mechanization as and operator comfort. So till 70s, people are only worrying about getting the job done, and till it took us a lot of years to really think of operator is an important parameter in that whole segment, and his comfort is also equally important. So if you see, especially in the construction machineries, the construction equipments like the long cranes or big backhoes and loaders kind of machines, most of the warranty claims and most of the complaints, user complaints, come to them like my AC is not working in the cab, right? Or there is a lot of noise in the machine. So these are all operator comfort things. They won't worry too much about if the backhoe's hydraulic is not efficiently functioning as it should be. Rather, they will complain if the AC is not working, because operator comfort is really important nowadays. 2000s, in the year of 2000 and that decade, guidance systems were started, and John Deere was one of the pioneers in that sector. We started with our own technologies like Navcom. Navcom is our company, that's 100% subsidiary of John Deere. Started enabling the GNSS or GPS servers, and a lot of uh, automation was enabled through those guidance systems. Uh, it is very important because you want to know where your machine is to take any sort of action, right? So day by day, this technology has evolved a lot. And believe me, today people talk about centimeter accuracy when they want to know what their machine is doing every centimeter of the field. And that's very, very important, because and you will see why it is in the rest of the presentation. You will see guidance systems, or GPS, precision GPS or GNSS system, really takes a major share in all the precision ag sector. Again, guidance enabled machines to do job optimization. So guidance was basically taken care to do precision planting or sowing and so on. But machine optimization is something really started 10 years later, where people started thinking about whatever the process they were doing, how they can further optimize that, how they can control each and everything they are doing in the field. And if you see 20s, there is of course definitely the increased optimization on the work side. I mean, it's not only machines, the whole work site is actually automated, and there are a lot of efforts going on in the robotics area, in the precision planting, spraying, and all those sort, which we are going to see in the next phases, next of this presentation. So to be just to summarize, mechanization again enhanced through engines and self-propelled machines really got us into precision ag, where the people started thinking about localization as well as positioning of that machine through satellite connections and GPS and those kind of technologies. Connectivity plays a major role, because connectivity machine to cloud brings a lot of opportunities of analyzing those data and analyzing the operations or optimizing the operations that machine is doing, and which in turn leads us to the automation. The pictures, if you see, the first one is a mechanical plow, and this is the plow that Mr. John Deere invented in 1834, where he started this company called John Deere, Deere and Company, and this was his first innovation, where he could make it a self-scouring plow, and that's where John Deere's innovation journey started. We started our tractor business through buyout from Waterloo Boy Tractors, and that's where John Deere got into tractors, and that happened almost 100 years later. But since first day of the business, John Deere has always been focusing on innovation and operator comfort and how to optimize the things. The third picture you see, these are like the precision equipments in the machine. The yellow ones, I don't know if you are able to see my pointer, but the yellow ones here are the GPS receivers, Starfire receivers we call them. This was again an acquired company for John Deere, sits in California, and each and every machine that John Deere sells in US, Europe, Brazil, or any part of the rest of the world is equipped with these machines, with these equipments, which gives us opportunity for precision farming. The fourth picture you can see is a innovation coming from a company called Blue River Technology, and Blue River Technology John Deere acquired in like 3 to 4 years ago, and that company has been doing a lot of work in terms of precision spraying. So when they want to spray the weedicides or pesticides, they actually spray it on the weeds, exact weeds, and they claim to save 90% of the pesticides going in the fields, or 90% of the chemicals going in the fields. Because of the technology, they can save the crop and only kill the weeds. And we'll talk some of these aspects in the next slides coming. So what is precision farming? Precision farming, there are many definitions available, but these are all my definitions. And when you call something that this field or this area is totally precision farmed. What does it mean? So when you have control on each and every seed that goes into the soil, so you exactly know where that seed has gone, precisely where it was dropped, how deep it was dropped, and how well it is cultivating. When you precisely can take care of each and every plant in the field, you exactly know what areas are there. And if you see the picture right here, can you imagine how precision would have gone into planting this kind of a field? So the horizontal rows and the vertical rows, wherever the horizontal rows are ending, the vertical rows have really planted with the same distance and same precision there, right? This is enabled through the precision technologies. So when you can precisely take care of each and every plant grows in the field, when you can monitor the growth of every seed remotely, you don't really have to go to the farm, and it's even impossible when you have standing crop and your fields are like 5,000 or 7,000 acres, which are typical sizes of fields in US. When machines know what every section of the farm wants, when your long boom sprayer, 130-foot boom, when you are spraying it with, it exactly knows where to stop the spraying and where to start the spraying. And when the yield is predictable, when you are harvesting, you exactly know what kind of yield I am going to get in what part of my farm, and what kind of settings I should have in my harvester so that the every grain in the field I can harvest in. When the season to season growth data gives opportunity to take corrective actions. So last year, whatever yield you collected from your farm, the machine keeps recording that yield. And then in the next year, when you again do your seeding or planting, you use that data and use high quality seeds where the yield was not as acceptable. Use more chemicals or less chemicals depending on the yield you got in every inch of your farm. So that is season to season opportunity to take corrective actions. And when one can plan, monitor, analyze, and take decisions and control remotely to your fields. So all these aspects you will see in the rest of the presentation. These are my definitions, and there could be many more definitions you can figure out. But in nutshell, the precision farming is actually all of these. And there is a level of how precision you want to have. Means it cannot be 100% automated. There has to be a human like intelligence to control things and take certain decisions. But to have those, there is a lot of data needed from that farm, and that really enables you to take those decisions. And how your machines become that intelligence, and how you can use the artificial intelligence to take that kind of decisions and optimize your growth of the plants as well as harvesting, and overall increase your productivity and profitability. That matters a lot. So I have tried to summarize in the rest of the presentation precision farming into all the sectors like planting, seeding, crop care, or spraying, harvesting, as well as I have also given some examples into nursery planting, nursery farming, which is a very growing business in especially in US and Europe. And I have also talked about dairy farming in the rest of the presentation. Uh, so automation in the farming and crop planting we'll see. So there are many mechanized planters. Mechanized planters have been there for years now, and they are getting smarter and smarter. So they really can control each and every seed that gets dropped into the soil. You can see these pictures here, how precisely they have maintained the distances between the rows as well as distance between every crop, so that there is equal opportunity for every crop to grow. There is a precise placement of the seeds in the ground, which maintains a specific spacing, which you can control again. So user can say, I want 6-inch spacing, I want 8-inch, or even you can go in centimeters. Singulation is very important. So you want to drop only one seed at one point of location. You don't want to you want to avoid doubles, or you don't want to avoid the misses. You don't want to see the misses, right? So doubles, certainly they compete with each other and stop growth of each other. Misses, you certainly don't grow anything there, and you miss the crop. So singulation is very important. And today's planters, those vacuum planters as well as precise planters, they really take care of those things. In John Deere, we use integrated seed motors. There are electric motors or DC motors we use to control each and every seed that is going into the ground, and they exactly can drop the seed which you want it to be dropped, want it to be dropped. So singulation in a corn is very easy, right? Because your grains are big. You can control each and every seed that is going in the ground. How about canola? Canola is a very fine, very small thing, seed, which is less than a millimeter depth, diameter. You want to still singulate it, and you want to avoid the doubles, and still drop one seed at each given point of time. So imagine the electronics and precision that goes into that. While you're dropping your seeds, a map is generated that shows the soil properties like quality, density, your nutrients in the ground, and at every point of the field. And you use that data again to for your sprayers to optimally use the chemicals that or growth hormones. And in the second round, when you once you plant and you see that some seeds didn't grow, and you want to plant those sections again, imagine the precision that goes in the planters. So they again go over the whole field, but only place their seeds wherever they were dropped. And that is something called precision planting. Means these machines have to be really accurate and intelligent enough. So there is a lot of precision goes into the GPS and uh, localization and positioning of the field, GPS and positioning of the implements, because your implements are really longer than your machine. Uh, John Deere uses 65 to even 80-foot planters, and they are really huge. If you see them, they require a 8 hour or 9 hour, like 600 horsepower tractor to be pulled to pull it. And those lengths, you still want to maintain your precision of planting as well as every seed you're dropping in the ground. Okay, moving on. Automation in spraying. Now you planted your seeds, and see the next second picture on the bottom side. This kind of field you want to spray your machines, spray your uh, farm, right? So the long boom sprayer, which I said like 130-foot booms, foot long boom, you want to control each and you want to control the area you are navigating through. You want to spray on the plants. You don't want to spray on the open field or pond or rocks coming in. Your field might have some sections where you did not even plant. You want to avoid those areas. So each and every nozzle of that plant, of that spraying boom, is controlled. And the robotic controls or the closed loop control systems in the machine, they actually take care of opening and closing each and every nozzle. They also take care of the wind directions. When the wind is blowing in certain direction, they actually can raise and lower their booms or tilt their booms in certain directions, so that the application of the spraying chemicals is exactly on the crops. Such a long boom, you can end up getting spraying into some other farms, right? If you are near to your end of headland, or you are taking a turn, you want to shut off those booms, right? Because you don't want to spray in somebody else's farm. There are many cases where people ended up spraying into somebody else's farm, and they had to pay a lot of money when the other guys sue them, wasting their crop by spraying wrong chemicals. So you certainly want to control that, and these machines also take care of those things. So electronic sensing and control brings a lot of it avoids overlaps. You don't spray on the area where you sprayed already, so you save a lot of money in those chemicals. Uh, Now using chemical itself is a dangerous thing. People want to avoid as much chemicals as they want. So there are weeders now, which robotic weeders, which don't even spray anything. They just kill the weeds with lasers as well as mechanical killing. John Deere, as I said, the Blue River technology, the company we acquired, uses cameras for the precision spraying, and that can save a lot of chemicals for you. Connected machines use that data from each other. So even from prior years, I said earlier, when there was wherever there was the harvester marked that there is not good enough yield, you want to take care of those plants or that area more. So the machines can actually talk to each other and take controls and decisions. These are some insights on the spraying, and there are many companies which have precision spraying solutions or technologies available. John Deere is certainly having those technologies, and day by day what is happening is the machines kept on getting bigger and bigger. People wanted more power, more speed, more area to cover in less time, and these machines always had to be bigger and bigger. John Deere has a machine which we launched in 2018. called SPFH, self-propelled forage harvesters. And very surprisingly, means that machine is 1,000 horsepower machine. It has a 24-liter engine and it's 1,000 horsepower. Imagine the power it carries, and with the harvester machine. But the problem with that machine is it has a the problem is not the power. You can always go higher and higher. You can use bigger engine, bigger things and all. The problem was it had to have a 1,500-liter fuel tank, and 1,500-liter fuel tank, actually we had to limit it to 1480, 1,480 liters. The reason is if you cross 1,500 liters, you have to certify your vehicle to fuel carrying vehicle category, and that is another headache and extra money you want to put together because you want to certify that vehicle for certain categories. And fuel carrying vehicles have a lot of norms or compliances in Europe. So we had to limit our fuel tank to 20 liters less than that, and people are still demanding higher machine, higher power, and higher chemicals. Oh, sorry, higher fuel tank capacity, which is not possible. So the ultimately, instead of making very big machines, people have started looking for smaller swarm of machines, and that's where the robotic kicks in. Your smaller swarm of machine actually talks to each other. They talk to each other. There are multiple smaller machines operating in the field autonomously, and then they take care of the fields, and those kind of discussions are happening all over the world. People are really thinking about those technologies. They don't want bigger machines now. They want many machines which can do a job of bigger machine without harming anybody or anything, right? Automation in farming, again, I'll talk about harvesting. So harvesters have really a big importance. They always want to harvest in certain time, certain directions, certain precision. They want to harvest each and every grain that's available in the ground, reduce wastage, reduce the grain losses and stuff like that. So a lot of automation has gone into those machines too. These machines have become intelligent, and there are so many settings you do. Harvesting combine harvesters are basically a factory by themselves. There are so many settings one has to do in that. And if you see the John Deere harvesting machines cockpit, combine, the cab of the combine, you will assume it's a cockpit. There are so many controls in that. For an expert operator, it's very easy to handle all those controls. But for a novice operator, we want that machine to take care of itself already, right? So that machine, in each and every section of the field or each and every inch of the field, it exactly knows what should be my settings. It looks through the satellite imageries, it looks through the cameras and all, what kind of grains are coming in, and it self-optimizes or self-corrects itself before it enters into that section of the crop. The down picture is the below picture is a cotton harvester. John Deere is a leading company. We have like 98% market share in cotton harvesters in US and Europe. And there is a lot of automation goes into those machines too. They're like factory by themselves. They process a lot of data, a lot of mechanization inside when they actually harvest the crops. Because you certainly don't want to lose the speed, lose the efficiency, but you want to also harvest each and everything that is available in the field. And while you are doing that, you also collect data so that you can generate a yield map around the field, which will be used next year by some other machines. These machines talk to each other. So when the harvester is ready, so there is a feature John Deere launched a few years ago called Machine Sync. And when the harvester, the cab is full, sorry, the grain tank is full, the machine actually gives a call to the tractor, which carries the trolley. When the trolley comes to near to the combine, they lock to each other their speeds and their turns, and the machine can optimally release the grain or unload the grains to the trolley itself. Uh, while unloading, if you take the turn of one machine, the other machine takes the turn by itself, and the user don't have to really worry about those things. That's called machine sync, and those kind of technologies go in harvesting. Moving on, crop remote monitoring and analytics analysis. There are many companies available today in US and even in Europe, like Gamaya, the AgroWatcher, the Precision Hawk. These kind of companies, they provide you data, analyze data for your field. What they do is they scan your field through satellite imageries. They scan your field through drones, and crop copters. Crop copters are basically small helicopters, remote controlled helicopters. Those carry a camera along, and they scan the whole field. They stitch those whole video into one single image, and then they analyze and give you data. What kind of yield or what kind of crop growth you are having, and then they do, and that's very cheaper available. I mean, those kind of services are available like 25 cents a acre or less than that. Now it would have gone a little less. In Seattle area, you will see a lot of companies doing that. So all those companies, people hire them. People want what's happening into their entire field, and they like scan. They charge you per scan, so they scan like 1, 2, 3, 7 times and all. And then each and every growth you can monitor, and the machines actually can analyze this data by themselves and take corrective actions while you are operating in the field, right? So there are companies, as I said already, like Precision Hawk or AgroWatcher. These kind of companies provide you all these data. Combines or any other machine, they are smart enough to understand that data and take corrective actions. The combine exactly knows what's coming in my way in 10 meters ahead of the harvesting path, what path I should take so that I can optimally harvest this. If there are any waterways, if there are any down crop situations, the combine can slow down, or if there is a not so dense crop, it can speed up and harvest faster. All those things, all those settings can actually automatically happen just connecting these combines with the cloud, where the already uploaded data from the crop analytics is already available. Moving on, nurseries and greenhouses. It's a big industry in especially in US and Europe, and even in India. Means India, you would have seen the gerbera farming and polyhouses and so on. It's a very growing field, and since it's a very delicate crop as well, you want to really have a lot of manpower to automate your operations there. Nurseries don't only take care of automating the watering operation, but they take care of a lot of other operations like potting, spreading, collecting, spraying, etc. So if you see these the pictures on the right side, the below picture, these pots are kept in the sun so that every pot can get better sunlight, and when they do a spraying operation, they also can get better chemical or even spreads, right? So imagine if you have like a very big nursery, and I'm talking about one nursery I visited in Augusta area, Augusta, Georgia. That was like 340 acres of nursery. At any given point of time, they had more than 1 million pots of nursery plants available. And if you want to move all these 1 million pots in a equal distance and equal places at various location every day, it's very hard to do that. So they have these kind of robots in the field. These robots are called harvest makers. It's a company who has made these robots, and they whole day or whole night they do all these operations. These robots, they exactly know their paths. They exactly know what pots I want to pick and where I want to place them. They also collect these pots and put it near the trolley, where the the person can haul them to the logistic where they again take it through the trucks to different markets. And these are I would have showed you a video. There are many videos available in Google or YouTube. If you just search this nursery automation, uh, they really work sync to each other. No robot collides with each other. They only work on the pots. If you put something else in their way, they won't pick that as a pot. They will just avoid that path and go somewhere else and pick other pots. Many companies provide automation solutions for seeding, watering, potting, warehousing, and many other operations. They get automated in the nurseries. Nursery is a big industry. It's like reaching about, if I'm not wrong, it is like $6 billion, and they have a growth rate of 25% each year. So they can afford all these automations. Moving on, automation in the dairy farm. So dairy farm is again another big industry, especially in Europe and US, and of course in India. Indian dairies are also getting a lot of automation for sure, especially in the feeding and cleaning areas. Milking automation, there are few dairies in India as well. They have a lot of automated operations in terms of milking. But globally, robotics dairy is a $2 billion industry. These dairies are pretty rich as such. Means if you see the down picture, these pictures are clicked by myself. It's a dairy called Larson's, and that's in Madison area in US near Chicago. These people had 5,000 cows at any given point of time. Sorry, 6,500 cows, and at any given point of time, 5,000 of those cows were milking, and others were like calf or you know smaller those sizes cows. So there has to be a lot of automation in this area. So a lot of their cleaning, feeding is actually automated. If you see the machine on the right, that's called feed pusher. It's a company called Lilly that produces these machines, and it's a robotic machine that goes in the feeding alley, because these cows will eat this forage. They eat less and spread more. And this feed pusher keeps pushing that forage again towards the cow, so that the cow can reach through that fences to the feed and eat properly. There is a lot of automation goes in milking the cows or cleaning those cows, or uh, there are drone herding. Drone cattle herding is another operation which is very famous, where these people have used drones to these people use drones to uh, hello, am I still connected?
Yes, we can hear you.
Yeah. So these people use drones to herd their cows, and they can make certain sound. They can drive, or they can fly into the areas where the cows have gone, and they can automatically even change their paths or locations, and they herd them so that they can all get into one direction they want to. So that industry is getting very well popular. This is a controlled environment, and it's very well possible in these areas, because this is a controlled environment. These dairy farmers are pretty rich, and they can afford all these solutions, because manpower is always less. Sensor enabled management. This is when precision machines that provide site specific controls. Means when I say site specific controls, means different part of your field need different attention, and these sensors exactly know where they are and what sort of actions they want to take. This sort of automation is always possible through various sensors. These sensors have to be synced with each other. They should sense, they should classify the information, they should analyze the information, and they should take proper decisions. They not only scan or sense the environment, but there are a lot of sensors available in the machines. So all those sensors work with each other in sync, so that they can take the precision controls. Machine to machine connectivity, as I said, is very important. Like machine sync feature, I said, tractor and combine, they sync with each other, so that they can match up to their speed. They lock their speeds with each other, and then they unload the grains optimally. If you are operating multiple combines in the field, and if your one combine is producing better output, their losses are low and their yield is high, you can actually pull those settings and put it in other combine without even getting into that combine, or without stopping those combines. The user doesn't have to bother. A person who is monitoring from remote actually can pull one combine settings, because all of them are connected with cloud and with the operator or the remote operator, and you can actually put those settings into other machines, so that the work site is managed that way. And it certainly enables new forms of data to drive the precision agriculture operations. So earlier it used to be a experienced operation. If you are experienced in your field, you basically could take better decisions. And now data has really played a major role in this, and your data actually tells you what to do. So all these things are getting enabled again through sensors. There are not only, there are various enabling factors like GPS, GNSS. GNSS technologies have evolved a lot. There are so many satellites, geostationary satellites roaming in the orbits, which gives you very precisely locations of each and everything in centimeter level accuracy. There are job monitoring sensors, which basically can tell you what is happening in your machines, not only good things but also bad things. Computer vision and machine learning has played a major role, because any robotics you imagine today, doesn't go without computer vision and machine learning technologies. And these machines are intelligent enough so that they also learn themselves on the go. Artificial intelligence, planning, optimization, these are all newly evolved terms in last 5 years maybe, and they have really ruled the world. Planning and optimization is another very important aspect because when you're doing an operation, and earlier you used to get into the field, start from one corner and finish your job with another corner. Now people are really thinking what sort of optimization I should do, or what sort of planning I should do, so that I can finish the same job in lesser time or more better way. Imagine like hay and forage business what John Deere has. There are baler machines. So baler machines are basically hay balers. There is a wind rover which basically harvest your hay or forage, and then they leave it for 3-4 days, 4 days, and once it is dried, a baling machine comes and makes round bales or square bales out of those, and that's getting popular as well in India. Now you want to pick those bales. So those bales have to be picked with a loader because they are too heavy. They are like 1,000 kilo bale. So you want to pick those, and imagine you have like 5,000 bales lying in your field. You can pick only one at a time, and you want to pick them. You want to come to a truck, load them in the truck, go back to another bale, pick one, go back to the truck and put that, or let the truck drive with you, right? So imagine how planning works in that, how the path planning is important, because what they say is baling operation is not expensive. Picking those bales and loading and unloading them in the truck and hauling them is very expensive, because they take days and weeks to just to collect those bales. The bale you are looking in front of you may not be your nearest bale, and the drone technologies and other technologies actually give you data which is your nearest bale, and how you should plan your path so that you can pick optimally, and save a lot of time and fuel and money. Machine to machine cloud connectivity I talked about. Remote monitoring and data analytics we talked a lot. Data analytics plays a major role. You can predict what's happening in your field. The machine predictive controls, your computers in the machine take care of those, and they can predict what should be the situation coming in your way, and what should be the optimal action you should take. Autonomous worksite solutions I talked about. So all these things have really enabled are the enabling factors of precision farming. In India or in our region, these things are coming, and these are the technologies are getting affordable. Earlier, price was an issue. These technologies were very expensive. The cameras are still expensive. If you want to have automotive grade kind of camera, those prices are dropping now. The controllers have become smaller as well as cheaper. The electronics has become smaller and cheaper and faster, and that has really enabled a lot of these factors. So industry is moving towards more and more for this precision kind of technologies. So in summary, I just conclude some of these points. So exponential technology change brings a lot of positive impact to farmers that enables industries to develop. So industries like us are compelled to develop and innovative solutions, because the farmers are demanding now. There is exponential benefits they are seeing. The precision farming solutions we call, John Deere uses that term as a trademark, precision ag and precision planting, precision farming, precision spraying, those kind of terms we use. There are farmers in the world who claim that they will not move a single inch if they don't have that technology enabled. We monitor those. All these machines are anyway connected to clouds and connected to John Deere networks anyway. So we keep monitoring how many hectares, and there are multiple millions of hectares in the world who are using these precision technologies to plant, to harvest, to monitor, to crop care, and a lot of other applications. Technology advances and access to the information, automation enabling technologies increase productivity, savings, and convenience. They certainly enable a lot of things there, and ultimately the technology is becoming cheaper, but the benefits are getting bigger and bigger. Data and data analytics make things predictable and controllable. I said already, these machines are self-learning, so they keep analyzing the data, they keep becoming intelligent day by day with this data, as well as they make your operators and farmers profitable. Autonomous machine productivity enabled continued growth in the machine system productivity. So autonomous is still evolving, but it is really fast in the evolution. There are many companies, many startups, and many big companies are taking a lot of interest in autonomous technologies. Every day, almost there is something new in the news that this company has done something autonomous. This company has done something autonomous. Even John Deere is doing a lot of things in autonomous areas, and these are all very fastly growing areas. Special needs of crops like apple picking, cherry picking, strawberry picking, those kind of technologies, those kind of farming, they need a lot of precision in the operations, and they and getting labor precise is again challenging. So they really are relying on these kind of technologies. Spraying, I said already, right? Means spraying is a hazardous job. You don't want your operators to be in the chemicals. You want to spray only where there are crops and only where there are weeds, depending on what you are spraying. And you want to save a lot of money as well as the health and the environment. Multiple opportunities in integrated worksite solutions. As I said earlier, farm, machine, crop, and the person or the farmer, they are all connected together. Even the markets are connected together, right? So John Deere has forestry as a business as well. I'll just give you an example where John Deere forestry business, there are technologies available, or they are in production for many years now, where the mill owners give orders to the fleet owner that this kind of I want this kind of wood, this long wood, this diameter wood of this size and this quality and this crop, and the machine exactly knows where in the map it is going to get those kind of wood. It goes into the forest, it harvests those forests, it cuts the woods, it can actually segregate the woods depending on the orders it has received, and it also updates the mark that these many woods have already been harvested, and I don't have to really harvest anymore, or don't have to send machines anymore, right? That's a different type of farming, but all these are like worksite automations. Tremendous opportunities we have. Autonomous solutions will augment the drive for safe, secure systems and will enable a transformation of business model. So the business models are transforming now. Normal farm owners are becoming entrepreneurs, and they have pretty much every control on their field, on their crop, and on their day-to-day operation, where they can decide, they can monitor, they can analyze, and they can take optimal decisions to increase their productivity or profitability. So that's pretty much my last slide. Thank you very much for this opportunity, and I'm open for the questions now.
Participants are requested to put their questions in the chat box. So the first question is, what is GN? Yes.
So you guys know GPS, right? Global Positioning System. So GNSS. The world really took a lot of time to understand that GPS is not the only. There is not only GPS there, but there is a network of satellites. So global network of satellite systems is actually GNSS, and that means when you say precision location, right? Precise location. The GPS can not give you a location precisely if it is relying only on one satellite. So normally normally the technologies actually rely on multiple satellites in the vicinity, and that's the reason they call it as global network of satellite systems, where they can trapezoidally take care of corrections coming from each and every satellite. At any given point of time, they are connected with 2 or 3 or 4 satellites, and then they really tell you exactly precise location of that particular GPS.
The next question is there is any agency in India for crop remote monitoring and analysis?
Those are evolving. I don't have names top of my head, but there are many startups who are getting into that area. There are companies who are investigating or investing in these technologies, where they monitor the crop and do analytics. But of course, the analytics has not reached to the machines yet. Unfortunately, it is with man and labor yet. But you can take decisions, and there are many connected services. So wherever there is they can analyze and they can tell you what we should be doing. These are community of practices. There are not commercial services as such available so far, but mainly community of practices are driving these kind of things. So in India.
There is okay, Sandeep. I will have one option with me. Actually, we have our own alumnus, and he has started his venture in UK basically. But
Uh-huh.
they have their operations in Pune and all over India. They are providing the data services.
Yep.
Kisan Hub is
Kisan
the
Hub. Yeah,
company.
Kisan Hub is the one. Yes, I'm
Yeah,
aware of that.
they are providing these kind of services, and they are also collaboration with us. So if
And
anybody is interested, we can provide that information.
not only that, one of your alumni, Vilas Shinde, he owns Sayadri Pharma, Farm Agro. He also has invested some money with TCS
That's
in these kind of
last
technologies. Yeah,
Sayadi Farms.
yeah.
Yeah.
Sir, the next question is what types of challenges are facing by the Indian farmers for adopting the advanced technologies in the field?
So uh, there are many challenges. One is unpredictable weather for sure. Second thing, the money that goes in farmers' hand is actually a lot of filtered money, right? Means because they don't directly sell their crops into the markets. There are many mediators in that, and final income is not that high, which can enable them to really buy high-end equipments. But when it comes to richer crops like grapes, let us say, grape industries has really evolved a lot. Means they can invest, and they are really investing a lot of money into these kind of applications for maintaining the quality of their farm sectors. But some responsibility comes on us too. As an industry, we should really boost ourselves to make technology available at a cheaper and cheaper rate, so that it becomes available and affordable to the farmers, and they can start using it.
Thank you, sir. The next question is, what is the status of cotton harvester in India, and whether your company is going to develop such a harvester in India?
There are some efforts going on in our company as well. The problem is the cotton harvesters in the world today, they really work on seeded cotton. And in India, people use 4x4 square planting type of planting, where the cotton really grows as a bush and it doesn't flourish at one time. They keep delivering the cotton, or the birds keep delivering cotton almost 3 to 4 months, right? And some people keep growing them again by watering them. So that technology has not been developed so far. There are many startups who are investing and doing some research around these areas. And John Deere, as a company, we have been working with seed manufacturers, how we can have better seeds who can give equal kind of quality as well as equal growth in the seeded cotton, so that the mechanized solutions can be there. But for
Okay.
now, there is no mechanized solution in the
Okay.
market for Indian kind of cotton.
Thank you, sir.
Sandeep, I
Next.
want to add here. In India, usually we are picking a cotton, and in other countries, usually they are stripping cotton. So in India,
Correct.
usually 4 to 5 pickings are there, and for that purpose, there is less automation. Stripping cotton means completely removing cotton from all over the field once and once only. So it is difference.
Correct.
So that is
Correct.
there is problem.
Correct. Correct.
Thank you, sir. The next question is, can we do automation for paddy farming? If yes, what should be the cost for 1 acre?
There could be a lot of automation in paddy farming too, because paddy farming, the lot of energy goes into preparation of the paddy field, and there could be a lot of automation. You can actually develop good levelers, good so that you don't have to really do a lot of passes. You can generate GPS solutions which will basically avoid duplication of the same land, or the soil compaction can be avoided. Those kind of things can be done, but paddy fields are again similar problem there. It has to be really affordable, because because if you go to south of India, the rice quality, even though the harvesting is too high there, the rice quality is not that great. Means not that richer crop there as compared to the north of India, and uh, still the practices are traditional. So there is a lot of automation. If you go to China and other countries, there is a lot of automation in planting and transplanting the rice there. But the challenge is in India, there affordability is an issue, and they still do manual operations a lot.
Okay, sir. Thank you. The next question is, brinjal harvesting is a difficult operation. Is there any precise machine available for brinjal harvesting?
I haven't seen any for brinjal harvesting, but I have seen cherry picking and even chili harvesting. I have seen machines. There are robotic harvesters which are kind of available. They are not popular yet. Maybe they are still in their early phases. But brinjal harvesting, I have not seen any machine. But if you can harvest chilies and other crops, there is possibility you can harvest brinjals too.
Uh, Thank you, sir. The next question is, how can we use robot for selecting suitable soil for particular crop?
There are no live sensors as such so far developed. Means there are sensors which are available, which are like offline operation, which tells you what kind of nutrients you have in your soil, and it's a offline laboratory kind of experiments you do and understand what kind of crop or what kind of yield you can get into that kind of farm. But there are no, at least I have not seen sensors which are live available, which are fitted on the machine and take on the go control of the things there. Robots can definitely help for sure, so that you can collect, the sampling becomes easier, and you can analyze data faster. But again, the technology has to be affordable. At least I have not seen any on the go kind of sensors available so far.
Girish,
Uh,
go
yes,
further.
sir.
Go forward because we have less time, so you can go for 2-3 questions.
Yes, sir. We have covered almost all questions. Can agriculture university have collaborative research with your company, and if yes, to whom we have to approach?
We're already doing collaborative research with your organization. Means we have pretty good relations with Rahuri Agriculture University, and Nalade sir is our relationship spoke there. So if you have any good concepts and you want to really approach, uh, of course, Dr. Nalade can help you. Dr. Pawar can help you, and you can connect with me. You can connect with. There are many other folks who are continuously in touch with your. In fact, we have a lot of alumni from your university there.
Okay. Sir, there is a one question that is one participant is asking that please throw some light on the projects which are to be allotted to the final year students of the BTech, so they can do work accordingly the present scenario.
Depends on which area you're talking about, because there are many such initiatives keep going in our company.
Uh,
We have a lot of research going on into sensing areas when it comes to soil and crop. There are many researches happening into image processing area, precision manuring, or like straight line navigations or navigation optimization. There are many areas people are working in, and of course with university relations. Uh, Depending on what area you want to actually talk to, means
Okay. Thank you, sir. The next question is there any harvester for onion which is designed by your company in India?
No. So we have been doing that effort through Tiffin. So John Deere and Rauri Agriculture University is pretty active in driving the Tiffin initiative. So Tiffin is a technology innovation forum for agricultural nurturing, and that's the collaborative competition we held at Rauri. And this year, because of this COVID situation, it couldn't happen. But I think December or January is the time we are going to have that. Last year we had it, and I was the convener there, and I visited Rauri frequently that time. But yeah, we as a company has not developed anything. Rather, we don't have plans just to develop one kind of onion harvester in the market. But we certainly want to encourage students to come up with some solutions, so that, and we'll actually help you taking it further or maturing it.
Okay, thank you, sir. We are now at the end of the session because we covered lots of questions asked by the participants.
Okay.
Just one question is, what is the scope of autonomous tractor in India?
In my opinion, there is a good scope of autonomous tractors in India because of multiple reasons. One, areas like vineyard or grape farming, there is a lot of automation needed, and getting expert labor is very challenging business. Second thing, uh, it's getting riskier. The chemicals, to have somebody in exposed to the chemicals while you are spraying, and spraying is a major operation in vineyard. You spray almost like 100 times in a season. So there is certainly a need of autonomous operation, autonomous machines in India. There are many other sectors like, as I said, poly houses are getting popular, and there are many poly houses in India. Probably that can be another area, certainly, because it's a controlled environment and autonomous machines can act better there. That there is certainly opportunity.
Thank you, sir. Now we are at the end of the session. I may request Dr. S.M. Nalaude, sir, organizing secretary of this online training program, to give a vote of thanks.
Thank you, Girish. So we are at the end of this very interesting session, and I hope most of the people who are thinking that robotics will not be a future technology, or how India could enter into this. So already companies like John Deere, they are in this very futuristic technology, which is already being used by many farmers in foreign countries. But India is having its own problems and constraints. So we have to come over those constraints. And I hope the lecture given by Sandeep is very informative to you. And you can, it will initiate your ideas. So it is inspiration for you people and us also to get into this new technology. So thank you very much, Sandeep, for your time, because I know you are very busy, even if you are locked down in your home under COVID, but you have a lot of meetings and you have to attend foreign thank you very much for this interactive session and giving all answers to the questions of participants. Thank you very much.
Thank you very much, sir, for this wonderful session, and thanks for the opportunity given to me. And I wish all your students all the best. And certainly, if you have any questions, my email ID is with sir. You can always connect with me. Okay.
Okay, thank you all participants for joining this session, and I hope tomorrow's session will be more interesting again, and we will be meeting again tomorrow at 10 o'clock. So thank you, Girish, Yogesh, and Shraddha. Thank you very much.
Thank you, sir.
Thank you,
Thank
sir.
you all. I'll drop now.